find the local maximum and minimum values and saddle points of the function. Okay, so what do you do first to find local extrema? What do you do? Find critical points. What do you do to find critical points? Take partial derivatives. Okay, so what's the partial of f with respect to x, where f is y times sine of x? There you go, y cosine x. What's the derivative of f with respect to y? Okay, and then what do you do with both of these partial derivatives to set them equal to 0? And you solve that system, and the solution or solutions will be your critical points, not necessarily extrema, right? But those are the ones we can check. So, all right, this one, when is that going to equal 0? Well, okay, you do have to keep in mind, let me restate that question. When are these going to both be equal to 0 at the same time? Definitely y equals 0 would be helpful, right? That would definitely get the top equation equal to 0. So here's the thing, guys. Cosine of x and sine of x will never be 0 at the same time. So it really just matters when the sine of x equals 0 to get the x value that's equal to 0. So let me say it this way. This guy equals 0 for x equals, well, think about it. When does the sine function equal 0? At x equals 0, x equals pi, 2 pi, negative 2 pi. Any multiple of pi, right? Any integer multiple of pi. So if we're solving this equation, sine x equals 0, then x is going to have to be k times pi, where k equals, excuse me, I'm a little off tonight. I'm a little off every night, but even more so tonight, where k equals an integer, right? So that's going to get you this equation equals 0, but that'll never get you cosine of x equals 0, that value of x. So it's really just y equaling 0 that gets you the other solution to the system of equations. So this is actually an infinite number of solutions, isn't it? So your critical points are k times pi, comma 0. These are I'll call them CPs for short. So what do you do to determine, which test do you use, big hint, to determine whether or not those critical points are actually local extrema or a saddle point? You got to find that quantity d, right? Second derivative test, and to perform the second derivative test, you always find that quantity d first. The generic formula for d, remember it's f sub xx, second derivative with respect to x both times, times f sub yy minus the mixed partial squared, right? And then really you evaluate for each critical point, although we can do it all in one fell swoop for these critical points, for each critical point, you would normally evaluate d at each critical point. And if d equals 0, how much information do you get? None. It's only if d is greater than 0 you can determine whether or not you have an extrema, or if d is less than 0, then you have saddle points, right? That's what the second derivative test says. So let's find f sub xx. So okay, look at that guy. What's that going to be? Negative y sine of x. What about, though, fyy? How about 0? Because it's with respect to y, right? Okay. And so that whole piece, f sub xx times f sub yy, is going to be 0 no matter what you plug in, no matter which critical point you plug in there. And then what's f sub xy? So this guy, and then cosine x. Okay. So d as a function D is going to be 0, right? This whole thing zeroes out, minus what? Cosine squared x. And then if you plug in any of these critical points, we can do it all at once here because we're going to get the same value for every single one. If you plug in any of these critical points, then, okay, technically, so I'm going to write it like that. What's the cosine of k times pi? It could be one of two numbers. Could be 1 or -1, right? But you're squaring it, so that is that really going to come into effect here, whether it's plus or minus 1? So I will just put in here plus or minus 1. Realize what this is. This is the cosine of x evaluated at k pi. And it's if k is 2, then it's positive 1. If k is, say, 1, like an odd number, like 1, cosine of pi is -1, right? So, but it doesn't matter because you're squaring it out. And so what's the value of that thing? It's -1, which is less than 0. And so every point with input k times pi comma 0 is a saddle point. Okay? So if you want to plug those values in the function, what would you get? So these are critical points that produce saddle points, right? And depending on which Calculus 3 book you look at, you'll include the z value and say that's the point, right? That's the saddle point. I kind of prefer to include the z value on saddle points. So looking at the original function, what's the function value going to be if you plug in k times pi? 0. The function value will be a height of 0. So f of k times pi comma 0 is going to be 0 times sine of k times pi, but that's 0, right? So what are your saddle points? K, pi for the x coordinate, 0 for y, 0 for z. These are saddle points.